Hello everyone, it's good to have you here. Thanks for joining X and Y. Either you're watching live or you've downloaded a video, it's all good. Grade 10s, this is a good time. The foundation is very important to lay whilst you're in a high school. Math is a crucial subject. You need to always score and get quality codes. So we're here to assist, here to help you get clarities on some of the questions that are challenging, learn more, and improve your results. So the focus today is going to be based on exponents and exponential equations. There will be two sections on this topic. The simplification of exponential expression will be section 1, and solving of exponential equation will be section 2. So if you are with us, just grab a calculator, grab a pen and a paper, so you can also help do some questions here and there. So let's get into it, guys. Let's solve for x and y here with me, if you are live with me. Alright guys, we would first look into the laws that we studied in grade 9. Exponential laws. Obviously we need to know what is an exponent. When I have a letter or a number with anything, be it expression, be it a variable, one term, whatever that is given that has something on top of it, this is your base and this is your index or exponent. So the laws that governs this exponent is what I've listed on the left side of my screen. I'm going to review them one by one before we get into solving questions. So the first law has to do with multiplication. When two exponents multiply each other, the law says that you keep the base, you add the index. That is your first one. Number 2, when you have exponents that are dividing each other, what happens is you keep one of the base and you subtract the index. So division goes with subtraction, and then multiplication goes with addition. That is the first two laws. Going further to the third one, well, the third is just a removal of a bracket. You've got two index, so when you remove the bracket, the index are going to multiply each other. You keep the base as it is, and then the index will multiply. Go to your fourth one. When any variable, a number, raised to the power 0, it always changes to 1. Example, even if I say 1000 to the power 0, the outcome will always be equal to 1. And number 5. Number 5 is very important, it's very crucial, because most learners find it difficult to simplify when they get an exponent with a negative index. With a negative index, they find it difficult to simplify. What I always encourage is that block your negative and take the index as a denominator. The negative becomes what? Becomes a 1, which is an inverse of the original exponent. Hence, you changing the negative sign as 1 and you taking the rest of the exponent without the negative sign as a denominator. Example, with a variable, take your negative as a 1 and the remainder, which is x to the power of a, becomes a denominator. So you can change anything. If they give you x to the power -5, it's simply going to be 1 over x to the power 5. You take the negative as a 1 and you drop the positive in this. Likewise, you could be given a fraction and you would have to be able to change it to a negative index. So it's either you're working from negative index to a fraction, or you are working from a fraction to a negative index. Both are very important skill that you need to master. Then the last one, where the exponent has a root. So in this case, removing the root has to do with either it's a square root, a fourth root, a variable that has been used. The index that is on the exponent will maintain where it is. Then the root becomes a denominator on that. Example, if I'm to do a square root of a 4. Remember, 4 is to the power of 1. This can be rewritten as 4 to the power 1 over 2, because here a square root has a 2 on this. To simplify this further, you could say 2 to the power 2 times a half, and that gives you 2 to the power 1, and which is equal to 2. That is why when you say square root of 4, your outcome when you punch in a calculator is always what? 2. The root becomes a denominator on the index that is given. So put that in mind. Without any further ado, I would take us straight into application of all these laws that I've just explained with examples. So we're going into example 1, which we are to simplify. We have to simplify 81 over 16 to the power 1 over 4. So if you have to simplify such exponents, this is still grade 9 question that I suppose you must be able to do. The best way to go about this is to be able to change this number 81 to a prime number with any index. That will still give you the 81. Change 16 to a prime number. When I say prime number, it's the fact that if you change to a prime number, you can not further simplify a prime number, because prime numbers has always got 2 factors. The number itself and 1. So 3 to the power of 4. 3 is a prime number. It will give me 81. You can check this on a calculator as well. 2 to the power of 4 will give me 16. Whilst I'm simplifying this, examiners always make you see the mathematical behind what you're doing. The original question had 1 over 4. In a sense, you simplify to be able to eliminate the 1 over 4. Hence, when I look at 3 to the power 1, it doesn't give me 81. 3 to the power 2 doesn't give me, but 3 to the power 4 gives me what? 81. And also, 2 to the power 4 gives me what? 16. Going further to simplify, 3 and 2 are sharing the same index, so I can put them together in one bracket and say both of them are to the power 4. Not forgetting that I had 1 over 4 already on my bracket. And to simplify this further, 4 times 1 will be 4. So 4 times 1 will give you 4, and 4 divided by 4 will give you 1. My answer finally will be 3 over what? Over 2. Because 4 and 4 can cancel each other. So this is an example 1. This is a very simple question. This is a level 1 question for grade 10 because it's a grade 9 content. Let's go to example 2. Example 2. Here's what we have. Example 2 also, we have to simplify an expression. So it's 2 to the power x plus 1 times 6 to the power x, 3 to the power x, to bracket 3 over 8 to the power x times 12 to x minus 1. So simplification means you simplify to the simplest form without leaving anything behind. So let's see what we can. So when you have this kind of a question, also the approach must be simplify the bases that are not prime numbers, all of them to prime numbers. So at the end of the day, if you have any prime numbers that are the same, you can apply the law. Hence, I've highlighted 6, 8, and 12 to be able to work on. Look out for factors of these numbers that are of a prime numbers. So I'll maintain my 2 to the power x plus 1 because 2 is a prime. But I can break 6 into 2 and have 2 to the power x as well as 3 to the power of x, because 2 and 3 or 2 times 3 will give me what? Will give me 6. And going further, this is a bracket, so we can apply one of the law. There's what? There's an index on the exponent. So when I remove the bracket, I will have 3 to the power 3x, or divide by, on the denominator I can also split my 8 to a prime, which means 2 to the power of 3 will give me 8 times your x will give you 2 to the power of 3x. You go further and split your 12. 12 would have to be 2 ways. Someone will choose to use 4 and 3. Someone can choose to use 2, 2, and 3. So whichever way you go, you'd always have to break them down into what? Break them down into prime numbers. So 4 times 3 will give me my 12 and to the power 2x minus 1. But you still need to break the 4 further to a prime number, which will then give you 2 rather, which will give you your 2 to the power of 2, which is what? A prime number now. Let's simplify further what I have. I would have to remove this bracket since there are 2 bases there. So rewriting this, I would have 2 plus 1 to 2 to the power x plus 1. I have my 2x, 3 to the power x, and then times 3 to the power 3x, or divide by 2 to the power 3x times 2 to the power 2 of 2x minus 1. Because this base is taking that exponent, and again 3 is going to take that index as well. Remember your board mates, you always have to simplify your brackets wherever you come across them before you apply even the law. So I will still repeat whatever that I have in step 2 and simplify the brackets that is on the denominator. At this point, this 2 is going to multiply out here on both terms. So I'll keep this, and that will give me my 4x minus 2 times 3, 2x minus 1. Okay, so boys and girls, at the moment, what we see is all the bases are prime numbers now. So we can now apply the what? Apply the law. It doesn't also necessarily mean every question that you get, the question will be in a form that you have to change everything to a prime number. But then this type of a question, it helps you to simplify the question in that manner, that you don't leave anything unchanged or anything behind. So the law now comes into question. I'm going to tackle the base 2's with the multiplication law and the division. So wherever there's a multiplication, I'm going to keep a base, which I have got 2 bases on top multiplying each other here. So when I keep the base, what I'm supposed to do is to add their index. So this index is going to be added to that one. So these 2 have been crashed down to this. There's one here which is dividing these 2. So this index is going to go up and subtract from what was existing there. Then we have this one also here, which is also dividing whatever that was on top. So the index is also going to go up. But in this case, there are 2 of them. This is 4x, this is minus 2. When I'm taking a plus on top, it's going to be minus. And when I'm taking a minus on top, it's going to be a plus. So that is the base 2. I've moved everything on top, and there's nothing at the bottom at the moment. So the law has been applicable there. Then I move on to my base 3, which we have x on top of the first one, plus 3x, meaning I'm working with these first 2, and the 1 as the denominator. Again, there are 2 terms here. So when I'm taking 2x is positive, it's going to turn to negative, and the negative 1 will turn to positive 1. Good. I hope you're following. At this moment, what I have here is to simplify the index by grouping like terms. So I do have x, 3x, and 4x. So x plus x will give me 2x. 2x minus 3x will give me negative x. And I will end up having negative 2 to the power negative 5x. 1 and 2 will give me plus 3. So the base 2 simplifies to this at this moment, times, let's check your 3, x plus x will be 4x, minus 2x will give me 2x plus 1. You still need to simplify this further, because I see a negative index somewhere there on top of the base 2. So first reverse these bases because of the binomials that the expressions on top, the indices are 2 terms. Reverse them first and then change the negative index. So this is going to be 2 to the power negative 5x times 2 to the power 3 times 3 to the power 2x times 3 to the power 1. So reversal of the law again and simplify further. So at this juncture, this 1, which is a negative index, can be written as 1 over 2 to the power 5x. Remember the negative index law. How did we change that? Your 2 to the power 3 is equal to 8. Your 3 to the power 2 remain as it is, and then 3 remain as it is. So in going further, what we can do is to multiply the numbers that are numerators. So 3 times 8 times 1 will be 24. times your 3 to the power 2x, all divided by 2 to the power 5x. Now, as we stand, we don't have any bases that are the same. You don't have a number at the denominator that will cancel 24. So you will leave your answer at this point as the simplest the simplest form. And I hope you did grasp all the steps that I followed in simplifying or in doing this question. So I would move further to example 3, type of a question where we need to work out common factors. So this is also grade 10 content level. You need to be able to master this. It takes you further to grade 11, and when you reach grade 12, you're still going to be applying this content. So this part is very crucial. We need to pay more attention to understand this example that I'm going to do. So let's get into it and see what we have. So I'm just moving the slide. All this is going to be there. You can pause, replay, and follow the steps again. If you have any questions, if you miss any point that I did not make it clear, you can always share a comment on the platform, and when I look at the messages, I'll be able to respond to your questions that you may have. If you're watching us live, you can also ask your question and you'll be able to answer you directly. Okay, so I'm looking at example 3, which involves a common factor. So example 3 involves a common factor. Question says simplify 5 to the power x minus 2 x minus 1 all divided by 8 times 2x plus 1. So with this question, what you need to pay attention to is to look out for same exponents. So if I look 2 to the power x and I look at 2 to the power x, in this I have a same exponent. That is why common factor becomes our skills that we need to acquire in this section. So how do you deal with this question? First of all, you must reverse this term here. You must reverse this in terms of the law that we have applied, the multiplication law. When you have two bases that are multiplying, you add their index. So in reversing this, if I was supposed to apply the law, I would say keep the base, add the index, which will be x plus minus 1. But the plus will not be counted, so the minus sign takes over the plus. So when I reverse this one, this is what I get. And it's very important you understand how to do this reversal. Otherwise, you won't be able to solve this type of equation. Then you go further and look at 8. 2 also to the power x plus 1. This is what the index is, a binomial. So you reverse the index as well with the multiplication law, which will be 2 to the power x times 2 to the power 1. So at this point, your next step is to look at your numerator. You want to look out for a common factor. A common factor. There are two terms in these numerators. but between the two there is a common factor. So with a common factor, we can see there's 2 to the power x here, there's 2 to the power x here. So 2 to the power x becomes my common factor. Hence, I've picked up my common factor. On each side, I'll be left here 5 minus 2 to the power negative 1, all divided by 8 times 2x times 2 to the power 1. It's a very important question because this is a grade 10 level. Now that I've taken out a common factor, the idea was to be able to what? To cancel out the 2 to the power x so that I'll be left with numbers to simplify further. I'll be left with numbers to simplify further. So with this question, what I have at the moment is one, you will be able to cancel out this guy and this guy, and then you are left with what is in the bracket. If you grab your calculator, 5 minus, what I wouldn't want us to mistake is this guy here with a negative in this. This is simplified as 5 minus 1 over 2. If you change the negative index to a fraction, you get 5 minus 1 over 2, all divided by 8 times 2. 2 to the power of 1 is 2. So 8 times 2 give you rather 16. Moving further, at this point you can even punch this information on the calculator and get your answer out. So 5 minus 1 over 2 will give you 9 over 2. If you punch it on the calculator, you have your 9 over 2, all divided by 16. Mathematically, 16 is sitting alone. So if you have to simplify this, it's going to 9 over 2 times. When you simplify a fraction over a fraction, you flip this one, reciprocate the second fraction, which will become 1 over 16. And this will then give you 9 over 32 as your final answer in the simplest form. So guys, that is example 3, which has to do with a common factor. A common factor that you easily take out and then you simplify further what is in the question. The example 4 that I'm going to work out with you is a little bit complex, but it's still grade 10 content. You need to understand this will end you up having to combine exponents with factorization. Exponents with factorization. You're not just going to take out a common factor, you're going to factorize the expression that is given to you. So I'll go into that question. That will be our last question for this section, and I'll drop a follow-up homework with 3 questions that you can practice on your own at your own time and see how you've understood the content. So example 4, the question is 6 to the power 2x plus 6 to the power x plus 1 minus 7 over 6 to the power x plus 1 plus 42. So here you can see the question has been intensified, but what I want you to pay attention to is this. What differs from the previous question and this one is that one exponent is twice One exponent is twice or double of the other one. That is what I want you to pay attention to. One exponent is twice or double of the other exponent. So if you can see, this is 6 to the power x, but this is twice of this one, 6 to the power 2x. So it would end us up working out a lot because the question has slightly changed. So let's first see how would you simplify such a question. Not forgetting factorization will come handy. So the factorization part, you would have to bear with me, and then we work it out, factorization process within the exponent. So first of all, in simplifying this, I'll keep the 6 to the power x and remove the what? Remove the 2. It's still the same. I've just reversed one of the laws, which says when you have exponents and there's a bracket, you can multiply. So if I say x times 2, it still give me the original question. But the reason why I've separated them is that I want you to see the term that has been repeated, or the exponent that has been repeated, and then be able to find a way to simplify it. Then when you go to the next one, this is a binomial. So I'm going to reverse the binomial as 6 to the power x and 6 to the power 1, then minus what is 7. The minus 7 is a constant, so you leave it as it is. On this side, I'll have my 6 to the power x times 6 to the power 1 plus 42. Alright, so as it stands, you can work it out direct by looking out in terms of factorization and solving the question in a factorization process. But to make our life easier, I want us to use a method called K method. Using K for the repeated exponent, which is your 6 to the power x. So let's say let K be equal to 6 to the power x. So wherever we see 6 to the power x, we're going to replace it with a k so that we can simplify this question further. So here I see 6 to the power x. I'm going to have k squared plus, I see 6 here to the power x. I'll say k times 6 and minus 7, all divided by k times 6 plus 42. So what do we see here is k squared plus 6k minus 7 over 6k plus 42. Obviously, grade 10, you've done factorization. That was part of your term 1 work. So this trinomial is quadratic because the highest index is what? Is 2. So for us to be able to go further and simplify this, we need to factorize the trinomial that we see on top there. So factorization becomes handy. That is why I said we need to look out for that. And also your denominator, you'd also look out for factorization because there are 2 terms there. Alright, so with this, the coefficient of k is 1. So factorizing this, your focus must be on the constant. You look out for factors of what? Of 7, where in this case 7 is a prime number, so the factors of 7 are always what? The number itself and what? Which is 7 and what? 7 and 1. These are the factors of what? Of 7. Why are you looking for these factors? This is your factorization process. You're looking for two numbers of the constant. When you multiply, they must give you a -7, and when you add, they must give you a +6. So in this case, 7 times a -1 will give me -7, and 7 minus 1 will give me a +6. Hence, let's bring it into our brackets. So k squared, obviously you split the k, so it's going to be k and a k. You'll have your +7 on top and then your -1 at the bottom. Then on the denominator, look out for a common factor. So your common factor, 6 can go into 47, 6 can go also into itself. So 6 is a common factor. When 6 is out, I'm left with k here. And when 6 goes into 47, it's going to 42, sorry, it's going to be 7. 6 times 7 will give me 42. So as we see, the top and the bottom, I do have a common bracket that I can cancel out. My k plus 7 and my k plus 7, leaving me with k minus 7 over 6. But that does not end there. That is not the end of your solution. Remember, you choose that k must be equal to 6 to the power x. So let's bring that guy back and replace it here. So it's going to be 6 to the power x minus 1 over 6. That will be your final solution. I hope I made sense with this type of a question. This is a typical grade 10 question which has a combination of two topics: your exponential expression, along that you ended up applying factorization in getting your answer to the simplest form. With that, it's been a good time having you here. It's been a blessing. You learning and you improving your knowledge and working hard to improve your results. This is very important for you as you are in a high school. You can't take any chances. If you don't build a foundation now, it's going to be difficult for you as you progress through the grades. So this is the time you need to solve more questions, do more questions, seek for help if you need help, ask questions when you have doubts and things that you're not clear of. I will leave you guys with 3 questions as a homework that you can work it out, practice it, and you can share it to us with me, and then I'll review, give you the answers to the questions if you have doubts on your outcome. So this is homework on episode 1. Let me hide this section so that people don't confuse the solution that we did with this with the homework. So episode 1 homework is basically 3 questions. And yeah, if you're able to work this out, then you're good to go. Great. Thanks, boys, girls, for being here. I hope you'll join me again for section 2, where I'll be dealing with exponential equations. As I said, these are 2 sections. You need to finish up the next section with me, that you join me live, or you can download the video and watch it at your own time. If you enjoy the section also, don't forget to like us and click on the subscription button join us for more sections, and also the notification button, join us, and then in the future, if there are any sections, you will be notified to be able to watch. Thank you once again.